Hello, so just going through the design section for the AQA A-level NEA project and what you need to make sure that you include and what you'll get the marks for. So it's out of 12 marks and what we're aiming for is the top band fully or nearly fully articulated design for a real problem that describes how all or almost all of the key aspects of the solution or investigation are to be structured. So we need to make sure that everything is clear what we're intending to do and how we're intending to do it. It's worth noting that this isn't a tick list, this is a few of the things which you can be thinking about on what you need to be including in your design. Every project is different and therefore how you're going about designing it, what different aspects you need is always going to be different. This is just a look through and a few hints and pointers and tips and things to be looking at. In your objectives, in your analysis you should have objectives. I would highly recommend that you link those objectives through. So they should already be numbered or indexed or referenceable somehow. So in your design, take every opportunity to say, I am doing this because this objective says this, therefore I need to do that. I'm storing this game file because objective 5 says that I need to be saving the game progress. This says that I need to do this processing to the data, therefore I'm doing this algorithm. So linking whatever you can, because these objectives which you did in your analysis should be the building blocks and the explainer for your entire project. So therefore you shouldn't really be designing anything that doesn't have a reason. If you are, then either you're designing something which isn't necessary for your project, or your objectives didn't cover enough. If you feel there should be that there, surely there should be an objective there. Again, rule of thumb, but have a think about it if you're doing something where there isn't an objective. So what sort of things can you include in your design? One of the things which might be useful is a hierarchy chart. So it lets you break down the project. If you have a look on YouTube, my YouTube channel, you'll see a GCSE project videos which have 2 videos on structure charts. It'd be worth having a look at those. I do recommend doing it on paper and sort of doing it up neatly afterwards. Essentially it's, this is your project, what are the component parts of that project, and then breaking it down, breaking it down, breaking it down. It's a nice way of just breaking a problem down using decomposition to show what are the component parts and making them more manageable. So if you do it by hand, then I would then recommend using draw.io or something similar to then write it up neatly. Whilst this is good for when you're actually designing it, in your actual hand-in, I would expect something a bit neater. So most projects will have some form of interface. I usually jot something out like this to show what I want and where I want the different elements. I know when students were doing sort of battleships or Minesweeper, they were trying to program things without having a clear idea of how it looks. So this isn't just for the sake of the write-up, it is actually quite useful to have a broad idea of what it's going to look like, and then you can start saying actually this section is going to be however many pixels compared to this, which is however many pixels of proportions, and then you can really start thinking about how you're going to make that happen and how you're going to split it out into the different parts. It's thinking about what are the important things for you to be showing the interface for. If you just have one interface design and it's of your settings menu, that probably isn't that useful. But likewise, I've got one student who's doing sort of a maths quiz. If they do a different design, interface design for every single one of 100 questions, that's going to get pretty repetitive and boring and pointless. We've seen we see the design which you do for the first one. If the others are going to be similar, so be it. Just say that. This is what one of them will look like. Others may have a couple of extra buttons, however, this is the broad structure. That's fine. But it gives a good idea of what it's sort of thing it's going to be like. And if you do a diagram like this, or use a spreadsheet to have something in more of a grid system, that's great, and you can just dump whatever you've got straight into your design section. It doesn't need to then be drawn up nicely. However, if you're messing around and doing it on, say, Tkinter, then yeah, you can just put a screenshot of what you've created and sort of why you've got each of the elements. It's an awesome opportunity to draw in some of your objectives. So, must have the health displayed to the user, therefore this is there. So just drawing arrows to say why you've got different aspects and how they link in the objectives. A class diagram is really useful. If you're doing anything with classes, then this is one of the early things which I do when I'm designing the project. So a lot of my projects, I'll say, okay, what are the different aspects? And it'll start off just being the blocks like student, classroom, and a student has multiple classrooms, and then I'll flesh it out and say, okay, what does a student actually include? What are the things a student can do? So have a look at the video class diagrams, and that shows a bit more details on how to do it. But it's really quite nice to have that information. Some of them can be quite complicated, and then it's even more important to have that and for clarity, but I do use those as part of my planning. But likewise, I've got halfway through a project and then decided, hang on, this should probably have a class diagram, and there are tools out there which will convert your project into a class diagram to help you visualize where all the data is coming from. It particularly helps when you've got things within things and, okay, I'm trying to get this version of the data, where do I need to go to, and so on. We're probably aware that a computer is just input, process, output with some storage. So too is a program, is a project. Each program, you put some data in, it does something to it, and outputs it, and it may store some stuff. Therefore, you can think of your program in this sense, and so you can do a quick table to say, okay, what is going into the program, what is coming out of the program, and what's it doing to it in the meantime. For the data dictionary, so you can have the key variables which you're going to be using, the key things which you're storing. It may not be variables, it may be what you're storing in various other places, a table, database tables, or things like that. Don't go too finer detail on this. This isn't looking for every single variable which you're using in a project. It's not looking for the I's and X's which you're using for things. This is at a broad level. This is the important things which you'll be referencing from various other places and such like. I've seen this defined as a definition so everybody knows what a term actually means. So if you're working on this with a larger project, I know this is an individual one, but if it was a larger project, you'd have something like this. So in this example, name and username, they're easy to confuse, and it needs to be very clear what each one of them is. In this particular one, I've done data type, a description, a scope, and example data. You could also have things like default values. This is just an example. You can do it how you want, provided you're showing the information which you need. So you may be storing data. Again, that goes slightly back to the inputs, process, storage, output. So if you're saving data, what data are you storing? What format does it need to be in? Do you need to have it that it's plain text? Do you need to have it that it's obfuscated? If you're saving a computer game, you're saving where they are in that state, awesome. And again, that may be from one of your objectives. The user may then go into that if it's a plain text file and then edit the data in that. I remember when I was younger that me and my sister shared a computer, and we'd have a bit of a rivalry on who'd be best on the high score on Minesweeper. We were quite young. And then one of us managed to find where the high score table was stored, and so we were able to actually go in and just change the high score. So somebody would spend ages trying to get a better score, would beat it, then the next day go in, edit the high score table, change it to your name, subtract 1 second from it, and then watch the infuriation as they try to beat the score again. So it's thinking about what you need to store, how you need to store it, and why. Okay, then you get into specific algorithms. This is partially where you should be showing off. What are the fancy algorithms? Where are you going to be getting marks for doing things which are really cool? This flowchart, which you can see, is a reasonable size. I've seen some projects which have an entire A4 sheet which should have been an A3 sheet, which is just full of a single flowchart. That's excessive. You're okay having a block which says, then decrypt the code. Yes, that's going to be a whole thing on its own, but if that's not what that flowchart's trying to show, then by all means generalize things. When you're looking at GCSE level, it's very much to a level where each block is essentially a line of code. So these are, that's going to be an if statement, that's going to be a normal statement, and so on. When you're working at A level or beyond, it's very much how is this algorithm going to work in general. So you don't need to be working with individual variables. You can simply say, has all the data been processed? Yes, in which case I'm going to do this with the data. No, in which case I'm going to continue doing this. What are you trying to show? And that's what you should be focusing on rather than the completeness. You can generalize things. There are various other things which you can do, sort of file structures. How are you structuring things? Is there a database? Is it going to be database design? So there's all sorts of variable things. So just to recap a couple of things, the spec says fully or nearly fully articulated design for a real problem. Try to link the objectives as much as you can, and do what is suitable for your project. This isn't a list of everything you must do. This isn't an exhaustive list. So it's up to you to do a design section which suits your project. And try and avoid trivial repetition. So if you've done a algorithm for how one thing works and you've got 10 of them which are pretty much identical, I don't need to see each and every one. So it's trying to make sure things are looking good, trying to get as many marks as possible and showing off. In broad terms, with your analysis, you should then be able to give that to another person and they should be able to create a project which meets your original goals. With the design document, you should be able to give it to someone else and they create a very similar project. So it should look largely how you want it to look. So if you did a design document for Mario, it may come out looking like a slightly dodgy Mario clone, but it should be recognizable all the same. Okay, I hope that helps and you can build something of a design document from that. Best of luck.